Welcome everybody to Blurring Boundaries, Deciphering the Risks of AWS SSM in Hybrid Landscapes. I'm super excited and hope that you are as well. Okay, cool. Yeah, so some basic information about myself. So I'm Ron. I have been a security researcher at Pantera, like Lior said, for almost 3 years. Amongst the different attack surfaces I had the chance to work on are the CI/CD, cloud in general, being more specific, AWS, and even more specifically, the AWS SSM component, which we're going to touch in a bit. Prior to that, I also had the experience of being a solutions architect at Pantera, so I do have some customer-facing experience. Before working in Pantera, I was a penetration tester. Sorry, it just takes a little bit of time. Looks for the slide to load. Awesome, yeah. Oh, I want to say that I'm a huge Lord of the Rings fan. Looks like we jumped to the agenda slide. So today we're going to talk about hybrid cloud environments. We're just going to introduce what they are, although I'm pretty sure that you're familiar with them. We're then going to talk about the process of transitioning from on-premise environment to hybrid ones. We're going to introduce the AWS Simple Systems Manager, SSM. We're going to talk about what it is, how it works. Then we're going to shift and look at it from an attacker's perspective. Okay, so hybrid networks. Look, we see here in the diagram a pretty basic setup, right? We have our on-premise network where we have some user workstations, some servers, can be application servers, can be file servers, really doesn't matter. Each business has its own setup. And then we see on the right side of the diagram, we see the cloud counterpart, right? So here for in this example, we have AWS. We see that we have some of the storage offloaded to Amazon S3 buckets, and we have the connection between the two parts. Can be a dedicated connection or using the public internet, to each his own. Now, let's talk a little bit about why companies are shifting to hybrid cloud. It offers flexibility and scalability, really easy to scale up. Data sovereignty and compliance. So one would ask, why not move everything to the cloud? We do know that in certain industries, due to some strict regulations, companies are forced to keep some valuable data off the cloud. So here is where this hybrid setup comes pretty handy. Cost efficiency, right? No need to put a lot of financial resources up front. Much easier to kind of come back up online using disaster recovery in the cloud. And the cloud providers, right, whether Amazon or Azure or Google Cloud, constantly innovate and let us have the experience with cutting edge technologies. So to throw out some technologies that I'm sure you're familiar with from the hybrid realm, we have AWS SSM, right? It facilitates management, both of cloud endpoints and on-premise endpoints. We have AD Connect from Azure that facilitates into kind of integration of on-premise Active Directory and the cloud one. And from Google, we have the Google Workspace suite with a plethora of different services for collaboration. And they also have tools of managing endpoints through the browser. So we've talked about, I mentioned AWS SSM, right? So we have various components. We have the fleet manager, which we're going to elaborate in a little bit. We have the session manager. We have the ability to patch systems, right? And as I mentioned before, the big advantage is that we can do it both on our cloud instances and the on-premise ones. So according to our research at Pantera, approximately 90% of enterprise cloud environments are implemented in a hybrid cloud setup. So we can definitely take away from this that hybrid cloud is relevant, it's out there, and we definitely have something to talk about. So think about how hybrid is your environment at the moment. So after we understood kind of the attraction and the value of hybrid environments for businesses, let's shift and look at it from an attacker's perspective. So in hybrid environments, the attack surface naturally increasing because we have both the on-premise part and the cloud one. Also, we have more attack entries. And another important component is the persistence, right? So in hybrid environments, let's take, for example, the on-premise section, where attackers can achieve persistence using the more traditional command and control payloads, creating new users, both locally and in Active Directory, for example. And if we're looking on the cloud side, for example, in AWS, launching new EC2 instances, creating new AWS users, etc. So much more avenues to achieve persistence. If you recall, a couple of years ago, we had the NotPetya attack, a devastating attack, which in a nutshell was a combination of Eternal Blue, a zero-day vulnerability, which gained attackers initial access on endpoints, and combining with Mimikatz, which allowed attackers to harvest credentials from the endpoints they got access to, perform lateral movement, and propagate their way further down the network. And many hybrid environments suffered, since even though the initial entry was on the on-premise side, the attackers quickly propagated to the cloud part of the environment and wreaked complete havoc. So we understand that the movement to hybrid environments offers us flexibility and scale, and that's great. But we do have some complexity in it. And this complexity leads to additional administrative overhead for the people who manage those environments. So the administrator will naturally look to simplify, automate, and kind of central manage the whole workload. So we're gonna elaborate and use an example kind of explain what I'm talking about. So here in the illustration, we have Joe, right, who is an IT administrator at a certain company, performing his day-to-day administrative tasks on his on-premise kind of comfortable network in a way, using automation tools. For the purpose of our example, let's assume that he's using PowerShell mostly. And Joe's CTO, Jeff, arrives with a request. Business needs dictate that we should move some of our assets to the cloud. For the purpose of this example, let's say AWS. Joe takes on the mission and begins transferring, as is requested, some of the assets to AWS cloud. After successfully doing that, he's now faced in a bit of a dilemma because he has two environments and he's not exactly sure how to manage both of them in an efficient way. Luckily for Joe, he stumbles upon AWS Systems Manager, which offers him just that, the ability to kind of central manage both environments on Windows using PowerShell, on Linux using Bash. And let's list some, not all, of the reasons that make AWS so attractive for administrators. As I mentioned prior, right, unified management. For one tool, we can manage both the AWS on-premise instances. Automation, tasks like patching, configuration changes, software updates can be done. Improved security, no need to remotely connect to endpoints using SSH or RDP. Everything is done securely using the AWS API framework using HTTPS. Patching configuration management, right? Can automatically patch on cloud and on-premise resources, while also having some extensive monitoring tools. Resource discovery, easy to kind of discover and list and follow on our different resources. And this way offering visibility, which is very important for administrators, especially as the environment scales up. Cost efficiency, we have one tool. We may be able to save up some funds on third-party tools. And a simplified network setup, right? No VPNs required. Everything is done via HTTPS, as I mentioned prior, mainly between the SSM agents, which we're going to talk about in a little bit, and the AWS endpoints. Now, all those reasons definitely make AWS SSM super attractive for Joe as an administrator. However, the same reasons also make it attractive for a possible attacker. So let's quickly go over AWS SSM. We've already seen this diagram prior. However, I would like to focus on a particular component, the Fleet Manager. Before we're gonna dive into Fleet Manager, just want to mention that the administration of AWS SSM can be done via the AWS console the AWS CLI or the AWS SDK. So the AWS Fleet Manager offers us kind of a centralized view, right, of the different managed nodes. We have information such as the node state, the name, platform type, etc. Also the resource type. And if we're interested in a particular node, we can click on the ID, which is highlighted on blue on the left side here. And then we'll have even more information, right? The agent version, the IP address, the instance role, etc. The AWS SSM agent, right? This is kind of the primary component that enables us kind of as administrator to administer and control the endpoint. So in essence, it's a piece of software which is installed in a pretty straightforward manner. Actually, in many AWS IAM images, it already comes pre-installed. Here we see an example, kind of screenshots of SSM agents running on Windows and on Linux. And I would like to point out an interesting thing is that they run with high privileges, system privileges on Windows and root on Linux. And as we know, high privileges do offer us as administrators a lot of flexibility, but they're also very much sought after by attackers for obvious reasons. And kind of continuing on that, let's see what makes SSM attractive for attackers. Centralized management, right? For attacker as well, if he gets his hands on SSM, he's able to kind of bridge the two realms. He's able to have access to both the on-premise and the cloud endpoints. And not only that, but with high privileges as well. And high privileges definitely facilitate his ability and probability of success in running malicious code. The traffic that happens between the AWS SSM agent and the AWS endpoint on a day-to-day basis, it's treated as something legitimate by default. Hence, the probability of somebody noticing something that is anomalous is lower. The binary, the AWS SSM binary, is signed by AWS. Therefore, we expect most EDRs to trust it, as opposed to some custom unsigned binary file that the attacker will try to upload and execute and will probably get flagged and caught. And kind of connecting to the second point, because the traffic as a whole between the SSM agent and the endpoints, the AWS endpoints, is deemed legitimate, we can expect it to be less monitored, therefore easier for an attacker to masquerade his activity. And now let's kind of chain everything that we've discussed to a couple of examples. Let's start with a pretty simple one, where we have an attacker that managed to gain access to a host. On that host, we have a user who has AWS credentials and is working with an AWS environment. The hacker successfully harvests those credentials and then is able to connect to the AWS infrastructure of that particular company and perform various malicious activities targeting resources such as S3 or EC2 instances. Pretty straightforward setup that we have here. And now let's take it to the next level. Let's see something a bit more, I guess, complicated in a way. Here we have the same hacker, right? And again, he managed to gain access to a host. Let's say this host is located in a certain segment called segment 1. As in most attacks, the initial foothold is not necessarily the end game for the attacker. He would like to propagate further and gain access to more valuable assets of his victim. So here, the attacker tries to get to segment 2, which holds some sensitive and valuable data and assets of that particular attacked company. However, due to correct and strict firewall configuration, he is not able to do so. So it looks as if he's isolated. Okay, he's on a host in segment 1, but he's not able to get to where he wants to. But luckily for him, and unfortunately for the company, that particular host does have AWS credentials on it. The attacker managed to harvest those credentials. He's able to connect to the AWS infrastructure. Using the AWS API, he's able to map the SSM managed hosts as a whole, focus on the on-premise managed ones, and he does manage to find managed host on segment 2. He's able to connect to that host and really perform whatever malicious deed he has in mind, whether data theft or possibly some ransomware campaign, or just achieve persistence. I'm not really exactly sure what he has in mind, but he's successful in obtaining that sought after access. So what we can see that basically happened here is that the attacker, using AWS SSM, managed to circumvent the effective firewall restrictions that were applied on the on-premise network. And now we're going to watch a demo, which going to chain the information examples even better. Here, the starting point is similar. We have an attacker that managed to obtain AWS credentials. We have here 3 scripts. First, the attacker will try to enumerate the SSM managed devices. In our case, he's going to zero in on the managed instance and the one that's online. He's going to retrieve the managed instance ID. He's going to use that ID and he's going to launch the run command SSM script, which will enable him to execute a command on the target host. Now, what he's going to execute? Here we have a simple SSH key extraction payload, whose aim is to search for and extract SSH keys on the target host. So let's get started and let's see how it goes. Sorry, Lior, can we get back maybe? Try to press play.
Yes, of course. Go back. No, can't see it working. Is it embedded on?
Yeah, it definitely should have been embedded. I can kind of, if it's not for some reason, I can kind of share it in live, I guess. That's I don't know if it's something that we can do, because now it just looks like a picture, but we definitely may want to see the video.
Yes. Let me see. We can share the demo. I have it with me.
Oh, you do? You have it? Okay.
Yes, I have it. Okay, so
Okay,
yeah.
awesome. Yeah, I can press and play.
Ah,
Okay, awesome. So here in this particular script, we're looking to identify the on-premise instance and the ones that are online, right? Awesome. Um, we see that we get the instance ID. Um, we see that we get its IP address. Then looking at the run command SSM, this enables us to create a client and basically execute a command on the remote target host. And here we see the payload, right? That will enable us to extract the SSH keys. Here, we're going back to the fleet manager. We can actually see the managed instance ID that we managed to extract using the AWS API. And we've executed the payload after specifying the managed instance ID. We see that it was successful, and we see that in the output, we get the SSH keys for both the root and Pantera privileged users on the endpoint. Cool. Thank you, Lior. Yes, we can.
you have the control layer.
Yeah, I think, okay. So, so let's talk about limiting the exposure. We would definitely want to use IAM roles with the least privilege principle in mind. What I mean is that we should monitor IAM roles or users with the permissions of SSM send command and SSM get command invocation, which will basically allow us to execute command on the SSM managed hosts. We would also like to rotate and encrypt our AWS credentials. And another interesting thing is that whenever the SSM agent is installed, a local SSM user account is created. A local SSM user account is created and added on Linux to the sudoer file and on Windows to the administrators group. So we definitely want to monitor the activity of those users as well. And another good thing will be to enable detail logging for SSM activity. We can use CloudTrail, for example. So to wrap it all up, hybrid environments are definitely here to stay. Simplification and central management are needed for those types of environments. Tools such as AWS SSM offer great flexibility and have great use cases that we have seen. However, we do know that sometimes powerful administrative tools can also result to be powerful hacking tools. Just as an example, think about PowerShell. And reiterating again, high privileges by default can be leveraged by attackers. Then again, definitely we should monitor the IAM permissions. So we came to the end of my part. So thank you very much for your time. If you have any additional questions, please feel free to email me. And for additional research material from Pantera, you can check it out at Pantera Labs.